Okay, this next part of the notes is called harmonic form, or auxiliary angles as I would have called it in the past. So solving equations of the form a cos theta plus b sin theta requires us to write it in the form r cos theta plus or minus alpha, or r sin theta plus or minus alpha, where r and theta must be found. Okay, right, we're going to look at this. If you have a cos theta plus b sin theta, we're going to compare it to r cos theta minus alpha. Now, if you do out r cos theta minus alpha, this is this side here, r cos theta minus alpha expanded would be r upon cos theta cos alpha plus r sin theta sin alpha. That's just from your compound angles. So if we just have a look, and this is equating, we're going to look at the coefficients of the cos theta. So here's our cos theta on the left hand side, and cos theta on the right hand side is being multiplied by r. So on the left hand side, cos theta is being multiplied by just a, and on the right hand side, cos theta is being multiplied by r and cos alpha. So this was us, how we've got this result here. We've equated the coefficients of cos theta to give you this result here. So this is where that comes from. So a is equal to r cos alpha, and that's my equation 1. The other way we could do this, I'll use a different color pen. Another way we could do this, we could look at our coefficients of sine. So here's my sine. So on the left hand side, you can see sine is clearly being multiplied by b. On the right hand side, sine is being multiplied by r and sine alpha. So this is us, how we've got this. We have equated, I'll go back to my blue. We have equated the coefficients of sine theta to get this line. So on the left hand side, b was multiplying sine theta, and then the right hand side, r and sine alpha was multiplying sine theta. Okay, so you've got these two equations, and then what you can do with these two equations is if you divide the second one by the first one, you're going to get the r's will cancel. So you're going to get tan alpha is equal to b divided by a, and then you can work out your value of alpha by doing the inverse function of tan. Okay, likewise, you know that r cos alpha equals a, r sin alpha equals b. So what you can do is square both of those. So r squared times cos squared alpha and plus r squared times sin squared alpha is equal to a plus b, a squared plus b squared. This then you could factorize out in r squared upon cos squared plus sin squared equals r squared plus a squared plus b squared. And this wee bit here, if I just highlight this, remember cos squared alpha plus sin squared alpha equals 1. So this whole thing just becomes r squared times 1, so just r squared is equal to a squared plus b squared, which means r is equal to the square root of a squared plus b squared. Okay, you will be glad to know in an exam, you don't need to do all of this, you just need to write down, once you get it to this form here, just write down r is equal to the square root of whatever this thing is squared plus whatever this thing is squared. But that's all the proof. Okay, I've gone through that quite quickly, but go through that again if you need to. Well, we will come back to all this later on. We'll just work through the examples, or you can look at this yourself even later on. I'll be just as good. Okay, example 1 says express cos x plus 2 sin x in the form r cos x minus alpha. So first thing we're going to do is just going to write it out the long way. Just say cos x plus 2 sin x is equal to r cos, and this is me expanding my cos x minus alpha. So that's r cos x cos alpha minus r sin x sin alpha. So equating, this is me equating my cos terms. So equate cos x, you're going to have 1 is equal to r cos alpha, and then equate your sin x, you're going to have 2 is equal to, and it's going to be, oh sorry, I've made a wee mistake in my expansion, that should be a plus there. So 2 is going to be equal to r sin alpha. Okay, now all you need to do here, remember we're just going to do our tan alpha, so therefore your tan alpha, and tan alpha is going to be equal to the sine over cos, so this one divided by this one, so tan alpha is going to be equal to 2 over 1, which means alpha is equal to, and I've just done 2, 1 to p, 63.4 degrees. Likewise, your r is going to be equal to the 1 squared plus the 2 squared and the square root. So r works out to be root 5, which is an exact perfect answer, and you'll see you would leave it as that in your answer. So your answer, final answer, is root 5 times cos of x minus 63.4 degrees. Okay, this example says, using the solution from example 1, solve x plus 2 sine x is equal to 2. So we're just going to say, first of all, rewrite the equation as root 5 times cos of x minus 63.4 is equal to 2. So therefore, cos of x minus 63.4 is equal to 2 over root 5. And that was on, remember, that is where minus 63.4 is less than or equal to our x minus 63.4 is less than or equal to 296.6 degrees. So got to do your cast diagram. Your basic angle, first of all, for me worked out to be 26.6 degrees. We'll do a recast diagram. And it was cos and it was positive, so it's going to be in here and in here. So 26.6 degrees, 26.6 degrees. So we're going to go round the positive way, and we're also going to round the negative way, because remember our range, we're allowed to go back to minus 63.4, so that's going back this way. So we have got that x minus 63.4 is equal to either minus 26.6 degrees, or it's going to be 26.6 degrees, which means x itself is going to be equal to 36.8 degrees. 36.8 degrees or 90 degrees. I will just check that. Sorry. Yep, and they are both between our range, which was between 0 and 360. So we've got our two values, and they're both correct. Okay, this is an example, as you would see in an exam. More than likely it will say solve 5 cos x minus 2 sin x equals 2. Now, in these questions, you can write this whatever way you want. So we've got 4 identities you could use. You could use r sin x plus alpha, r sin x minus alpha, r cos x plus alpha, r cos x minus alpha. Now, I just pick. There's an easier way to do, an easier one to use, but you're not going to get it wrong no matter which one you pick, as long as you just be careful with your coefficients. But in this one, I'm going to let my 5 cos x minus 2 sin x equal r cos x plus alpha. Now, the reason I've done that is if you expand the cos x plus alpha, well, let's just do it and find out. You're going to have r cos x cos alpha minus r sin x sin alpha. So first of all, you start with your cos x term when you use cos x plus alpha. So you start with cos x, and then your next term is sin x, and also it's negative, and here this one's going to be negative, so it just makes it a wee bit nicer to work with, that's all. But again, it wouldn't make a difference if you do a different way. Okay, I'm going to just equate coefficients of cos x, and that's going to give me 5 is equal to r cos alpha. I'm also going to equate coefficients of sin x, and if I do that, that's going to give me positive 2 is equal to positive r sin alpha, which tells me, therefore, that tells me that tan alpha is equal to 2 over 5. Therefore, you do tan to the minus 1 of that, and you are going to get 21.8 degrees. Okay, what else can we do? We can also say that r is going to be equal to 5 squared plus 2 squared and the square root. So r is equal to the square root of 29. Okay, what we have got the story so far then, we have got that the square root of 29 times cos of x plus 21.8 is equal to 2, which means cos of x plus 21.8 is equal to 2 over the square root of 29. Okay, we can go on from here and then find your basic angle. I'll do that over here. So BA, so I've just done cos to minus 1 of 2 over 20, or square root of 29, and that has given me 68.2 degrees. Do your recast diagram. And I should have said, sorry, the range here, I forgot to say the range was on, and it's going to be it's adding the 28, sorry, so this is going to be on minus 158.2 is less than or equal to x plus 21.8 is less than or equal to 201.8 degrees. Okay, so for this one, you do your basic angle. So you've got your cos here, sorry, your positive one here, your all one here, and your cos one, and the angles were 68.2 and 68.2, and in this case, our negative one fits in. It's fine because we're allowed to go back as far back as minus 158, so this is definitely okay, and the positive one fits in. So you've got so far x plus 21.8 is equal to minus 68.2 and positive 68.2. So your x is going to be equal to, and it's going to be minus 90 degrees, or it could be 46.4 degrees. Let's just check and see, are they within our range? Where is our range? It's up here. Our original range was minus 180 to positive 180, so they're both fine. So that looks pretty good to me. Okay, folks, you're now ready to do. Oops, this thing freezes. You're now ready to do topic 5. It's Trig B, exercise 4.